I think we have the diehard group of people that pretty much have joined every day of PrintFest. Thank you so much, guys. It's great to see you all here. It's also great for us to know that there's such a community interested in all the printing, and I always love also how supportive you guys are of each other. Also, yesterday was a great meeting with all the young designers. So today we are going to get into the actual magic of printing. Oh, there's Diego. Today we're going to get into the actual magic of printing, I always call it, which is the slicing software. So, hey Diego, morning. So what I'm going to do today, since I know that we have a very mixed audience of very experienced printers and novices, I will explain the slicing from the beginning, because then if you are a novice and I have to jump in like halfway through, then you're going to miss, the essence of it, and that's not what we want. We don't have speakers today because you guys are actually the guest speakers. If you have any file that you're struggling with, or any question or things that you run into, by all means, feel free to ask them. So today I am going to use Cura Slicer and Bamboo Studio, since I know that these are two slicers basically that you all use a lot. Um, Always happy to answer other questions. Of course, there are other softwares out there. There's Orca Slicer, there's Idea Maker, there's Simplify 3D. I mean, whatever you guys might use. But my purpose for today is really to make you understand the principles of slicing, how you can play with slicing, and give you some valuable tips from a footwear perspective on some little tweaks that you can do, for instance, to help your supports come off easier, stuff like that. Just like in the other classes, if you have any question, just interrupt me, open your mic, ask the question, raise your hand, whatever you want to do, because this is not a formal meeting. I have planned like a demo from our side. We have a demo model that can be sliced in many different ways. So I think that will be very informative for all of you to see. But I can definitely imagine also, like we had in the first class, that people are struggling with some things. They're like, oh, I was trying to slice this and it doesn't do that. Just let us know. So first I will start outside of the program just to explain on shoes and other samples what slicing does. And then I'm going to go into the actual software and do a live demo. And you guys are welcome to follow along with any model that you guys have. Oh yeah, remark for those of you that are in, I don't know if you've seen it, for those of you that are in the online printing course, the issue with the files has been solved finally. So I make now an ebook with the links to the files. That's actually also for the textiles course. I've made an ebook with the links to all the files. You already had the files, but if you need them again, then now it's finally now working, that all the files can be downloaded, and that also counts for the printing course if you guys are in that. And there were some example shoes. These example shoes you can now download, no problem. It's right in the top of the list of the course parts where you can then download. So that should all work now. So having said that, first of all, what is a slicer? Since we have a relatively small group, I'd like to understand who has experience with slicing and what slicer you use. So maybe each of you can yell out what you what you have. Jacob, you want to start?
Yeah, why not? Thanks to footballergy, courses.
Yeah,
Nowadays I have experience on Cura,
yeah.
and before that, I've been using Cheetahbox, for SLA
Yeah.
printing.
Oh, yeah. Yeah, yeah, for resin. Who wants to go next? I'll just yell out a name on the screen. James, do you want to say what you use?
Yeah, I use the Bamboo Lab
Yeah.
slicer, and I think I'm going to invest in a Neptune, so I'm trying to learn the Cura slicer as well.
We're going to
And
demonstrate for Neptune today, so that's going to be helpful for you then. Yeah.
yep.
Okay, cool. Michael Bierbaum.
Can you hear me all right? There you go.
Yep.
I also have experience using the Bamboo Slicer. I'm still novice in terms of experimenting with materials. So a lot of the information we've covered already has been super valuable, and I'm excited to test it out.
Okay. Perfect. Yeah, we'll cover some more maybe today also how to use some material on the Bamboo specifically. Daniel Andriessen. I think you're Dutch.
Yes, I am. I'm just using a Prusa slicer. Also used Cura as well, which does with all the basic settings. So I'm just curious what's all possible with your course today.
Yep, perfect indeed. So what Daniel's mentioning, Prusa slicer is also one of the main slicers. Actually, Bamboo Studio is based largely on Prusa slicer. So Prusa is also a printing brand and filament brand, for those of you that don't know, from Czech Republic. Mitchell, what are you using?
I'm primarily using Bamboo Studio because most of my printers now are Bamboo Lab printers. I also have a legacy Prusa printer,
Yeah.
and so sometimes I use Prusa slicer with that.
Okay. Oh, we scared of Alba. She left. Echo already let us know in the chat that he's using Orca. So Orca slicer. Orca slicer is not something I'm going to demonstrate specifically today. Orca slicer is a really good slicer for those of you that are a little bit more experienced slicers. Orca is also a good slicer specifically if you have models that consists of many different parts. Imad, what would you be using?
I'm using the Bamboo Lab slicer.
Yep.
Actually, there is one thing that, with the Bamboo Lab, the volumetric speed. So if I change the size of the
Yep.
nozzle, it doesn't
Yep.
really, it actually makes it longer, even with the larger size. Yeah, because of the, I'm not expert, but because of the volumetric speed, I understand. So if we don't change the volumetric speed, then the no matter how much you change the nozzle size, it doesn't really
Doesn't
change.
really speed up the flow.
It
so
doesn't,
you
yeah,
might
it does not speed up the flow. That's
linear height out of
so.
here.
Yeah, and the other thing I was going to ask, how can you get in touch with, because there's some of the actually the community here, they're really good at, and some of them that I think they would have the knowledge that would really need to answer some questions. How can I get in touch with anybody on the separately, like, if I want to?
What you can always do, so there's two options. So what you can always do is leave a message on the discussion group. But people that are here are in different courses, and some people have already finished courses. So what you can always do, if you have specific questions and you're struggling, let us know in the chat and leave your email address there. And then the others here in the group can then reach out to you and say, oh, hey, I have a solution for that, or I ran into that. So that's also working.
Perfect. Yeah,
okay,
thank
Ben,
you.
Ben says that yeah, Mitch, tell me.
Yes, could you please tell me where is this chat that you're mentioning? Are you talking about it during this meeting?
Right,
Or are you
okay, let me see if I can share screen quickly. I have to go in my backside. Let me see if I can go to one of the courses and show you. Let me go into the 3D printing course. Okay, and let's go to this one and do preview. Right. So let me share my screen. Well, this is funny. I'm just opening a video there. Diego sees himself. Always the first to show up in class. Now I'm in the 3D printing footwear online course. And then here's a video, one of the videos, class videos that you would then play. And then here on the left, you see path, which is all the different classes. Then you see learners who are in the course. So you can also always, because you'll recognize names here that are also now in this class. You can always click on names and ask people specific questions if you want to. And then here, there's discuss. So here, as you see, indeed, when the Google Drive link wasn't working, that's all. Let me see. I need to let somebody in. So there's Brian. So let me jump back to where I was. Where was I? Here. So here's where you can see all that. So say if I click on, this is my backside. Say if I click on a course, you see the classes, you see who's in there, that you can, and if you want to leave a message for someone specifically, you can click on them. And here you have the discussion platform. So this is where you can read, and every course has that. So this is where you can leave questions, and I usually answer privately or fix the issue, or if it's just something where you're like, hey, Can somebody respond to me, or I'd like to do this or that? That's also possible.
That's great. Thank
Yeah.
you.
All right, so let me stop sharing a second because I had not finished yet my questions. So some people came in. Okay, so Alex says Raise 3D. So then I'm assuming, Alex, if you have a Raise 3D, that you use Idea Maker, or what slicer do you? Yes, Idea Maker. Okay, so that's with the Raise machines. So for those of you who just popped in, we're just checking what slicer everybody's using, just to get some questions. Anthony, what are you using?
Yeah, I'm also using a bamboo slicer.
Bamboo slicer. Aratha, what are you using? I thought it was also bamboo, no? Or
I use FL Sun S1 Pro.
oh, so you
I-
you do
yeah.
Cura slicer?
I think it's based on all car slicer, I think, but it's a slicer that come with their software.
Oh, okay, their own
FL
slicer.
Sun slicer.
Everson's
Yes.
own slicer. Okay, I'm not familiar with that. Who did we miss still? Brian, are you just popped in? Are you using a specific slicer at the moment?
Oh no, I'm just a beginner, so I haven't
Perfect,
even
just,
gotten into that yet.
No, perfect. Then you'll get your first class today, and then I think the last one is Daniel Moreira.
Yeah, hi Nico. I'm
Hi.
used to use the Cura. Is my
Okay, so yeah, all right. So today, indeed, we're gonna. Mitch, tell me. Yeah.
Yes, I watch. I do a little research on printers sometimes to make sure that I stay up on things. I heard about some printers with tilting beds,
Uh-huh.
but
Yep.
the obstacle to using them, which they can be useful to help eliminate supports in a lot of cases.
Totally. Yep.
The problem to using them, I heard, is that they're lagging with the slicer technology. And I was just wondering if you or anybody in the group had heard about any up and coming systems like that, because to be able to eliminate supports would be, in the most difficult
Great.
situations would be
Yeah.
huge.
Yeah. Well, I mean, there you also have to be realistic. So indeed, it's true that you have a lot of printers coming to the market that, for instance, so there's a few solutions for that. So there's either, for instance, a bed moving so that the angle of the shoe changes all the time while the nozzle stays straight. You also have robotic arm solutions where there's an extruder to a robot arm that moves around the last. You also have them do both. So one arm moving the last, other arm moving the extruder on the robot arm. These are solutions that are coming, but some of them or most of them are still in research phase and are expensive. So for instance, you have to realize we work now with a new one from Germany. I'm horrible with names, so I have to look it up for you. It's not on the market yet. That is indeed a slicer that allows also for what I would say non-planar printing. So that means that you could also print around a curve, etc. But then you do have to realize that those slicers, of course, are complex. They're not free. So this, for instance, this particular software that we're going to test is 5,000 euros a year license normally. So these are just higher prices. I think if you are looking to print the shoes that you showed us on, was it Monday? I think Monday, yeah, the first class. You don't need that for the moment, because I think that you can eliminate a ton of your support by doing different slicing and different designs. So you're still welcome to send the shoe that you have to us and that we do a slicing for you as an example and say, hey, this is also how you could do it. I think you could do a lot there. Definitely the direction that you're mentioning is the direction that is coming. But of course, this is extremely complex for the slicer because there's so much more data that the slicer needs to handle, because the number of directions, of course, is not just plain XYZ. You have XYZ of the object, you have XYZ of different parts of your extruder. So it's highly complex to do that. So also for people who are beginner, I would definitely not advise to go in that direction. What you can do for those of you interested, let me see, it's this guy. Let's see if I can, if I can share my screen. Right. This website, some of you might know it, is Non-Planar XYZ. This is a guy in Canada who makes extendable nozzles, essentially, that allow you, as you can see here, to print on top of a curve. So on top of a 3D object, it allows you, instead of printing in straight layers, what we always do, to print around a curve. And this has to do, in his case, with the nozzle being able to extend. Because, of course, if you want to print in a curve, and normally you go in straight layers, and even if you have double nozzle, you don't want the other nozzle. John Gibson, who was in the class yesterday, mentioned indeed with his Solvo how the second nozzle often pushed his print off the plate. You don't want to have that. So there are more and more solutions coming. So he sells these nozzles. He also has some training on how to do that. It's something that you could look into. I don't think that for the specific type of shoes that you are doing for the moment, that you would necessarily need that. But obviously, yes, in the future, and also for industrial production, we see more and more of those systems coming. So I don't know if you've seen the shoes of Oxman brand. This is like completely 3D printed around. I can see if I can quickly find a picture, because it's maybe a lot to explain the whole process. They were also in our event last year. Let's see if I can find a picture of their printer. Yeah, here, but I don't know if you can see it. Well, let me see what this page is. Yeah. Okay, let me see if I can, just for those people that might not understand what I'm talking about. I'll share my screen here. So this is the company called Oxman, by Neri Oxman, very famous scientist previously from MIT in Boston. And she has developed this system. I'll play the video. I'll skip a little bit forward because I turned down a little bit the music so I can talk over it. So what they do is they made a full system to make a biodegradable shoe in PHA, which is a biofabricated plastic, essentially bacteria excreting plastic, which is PHA. They extrude it into a yarn first. This is what you see here, to make a knitted upper. And then you see a couple of early examples of this upper. Now you see them indeed then designing the shoe around that upper. And then here you start seeing that this is the type of system that you mean. So here you see a stationary nozzle with the robot arm moving the shoe underneath. They have different types of nozzles. Here you see a nozzle almost like a spaghetti machine. Really different type of extrusion, coating, whatnot. But you can imagine that slicing for things like this is a job as such. Here you see the printer. So yes, this will be happening. Do I see this at any point soon for a consumer or small business market? No. So because these are all things that are custom built, essentially. And what you also see, since we work with them as advisors, that these companies are struggling also to find the right people to create the slicing, because this, as you can imagine, is extremely complex to do. So it's very beautiful. It also has its own aesthetic. So, of course, these people are trying to reinvent the full supply chain in one go, both in terms of material, how you make the shoe, where you make it. Their labs in Manhattan. So very interesting, but this is all quite early stage. So there's not an example that I can mention to you like, oh, you could go and buy that now. So, and I think for also some of the shoes that we do, we don't necessarily need this yet. By the way, if any of you have other examples or other things that you've seen, of course, I'm also not all-knowing. Please feel free to interrupt and say, hey, Nico, I found this or I saw that. Yeah, this will take some time to come to fruition, this type of technology. So as you can imagine, it's expensive to build. Yeah. Anybody else already pressing questions before we start into explaining the slicing or issues that you want to know? Yeah, Thibaut.
Yeah, another question. Well, I just posted yesterday in Instagram stories. about the Print Start 3D workflow that they print horizontally, like but with overhang, with no supports, like 90 degrees overhangs with
Who
no
was that?
supports.
Who was that? The
I think it's Print Start 3D. I saw it in Print Start. It's in my stories.
Can you type in the chat? Because I could not really hear it well. I think I can look it up.
Let me.
Because you have also indeed the people printing with liquid and gel, and of course all that stuff. Then you don't need supports. I mean, there's a lot. If you have you have the printers that have the moving beds, where indeed you could do a 90-degree overhang if you just tilt the board 35 degrees. Then you also have your solution. So I know that Direct 3D, who our pallets printing supplier, has a printer that has a 45-degree print bed, which indeed helps a lot with preventing support. So if that's something that you're interested in, Direct 3D, they are in Italy. They are also in Footwear. So if you want to know more of that, I can ask him to bring that one. That's one of the only options I know now that I could say, hey, that you can buy. That's always the case. Usually when you want to try and find something on the spot, you're like, what was that?
I think you're referring to printing with concentric circles, right? So you can do like fully
Exactly. There it is.
cantilevered
yeah.
overhangs. Yeah.
Okay, well, let me go here and see what that is and share my screen. Okay, Full Control XYZ slicing software. But that will always, I mean, that also looks like a palette printer, because that also definitely, what I see here, let me see that I share again my screen. There we go, entire screen share, and I was here on Instagram indeed. Because that also looks indeed like the printer attaching to the side. And that also will have to be a material that attaches right away and has the exact right viscosity to not drop. What says filament? Filament Duramic 3D official. I mean, Duramic already sounds to me like a ceramic hard material. That's probably also what you need. One of the issues, of course, that we have using flexible is that our risk of stuff dropping is larger than if you do anything in a rigid material. So very interesting. Well, I'm definitely interested to see Full Control XYZ slicing software. Interesting. So I didn't know this one yet, so I'll definitely check it out. Yeah, this is PLA. Yeah, so, but okay, for PLA, there's lots of stuff that we can do that we cannot do in flexible. Is true. You will also see indeed that, so the things that we are specifically going to look at today are of course for flexible, because that's also where you can usually not use any of the standard settings that the printer suppliers come up with for the rigid materials, because it really works differently. So obviously enough developments in here, but nothing yet that I could tell you to really buy now. So any other questions before we start into the actual trade? Okay, no. So then we're going to start from the very beginning, just to explain the basics of what is a slicer even for. Because usually when people start with printing, they approach me with all kinds of questions on what 3D software do I need and what 3D model and this and that. And those are all valid questions, but the real magic happens in the slicer. And the slicer is the software that translates your 3D model to a print. And in that sense, it's not so different from simply even using an inkjet printer. There you also see that it translates it into all these lines when it prints it. And exactly the same thing is happening in the slicer, but in 3D. So it makes those layers that the printer is printing on top of each other. And then, as we have seen before in some of the previous classes, you have a difference between the outside of the shoe, which can be a closed ball or open, and then what's on the inside of the shoe that you usually don't see, which is the infill. So when we start with teaching people slicing, we never start at all with full shoes. And I also recommend for all of you that if you are just starting, is to simply start with small swatches. So when we have start with our beginner print courses and people come to our lab, these are the first thing that we have them do, like little cylinders or blocks. I mean, the shape doesn't really matter so much, but that you create something, and we will do it also in a bit in the slicer, that is closed maybe on some sides and then is open on one side so that you can see what the infill does that you have chosen. So here, for instance, you see that the outside, we call that wall. And I explained those yesterday, bottom and top. The side and the bottom is closed. This is walled. And the top we left unwalled so that you can see inside. And here we just have a grid. I think this is a grid. Yeah, it's a grid. Infill. And here we have a concentric infill. And then both in very different densities. So also if I squeeze this, I can squeeze this because it's a flexible filament. But I can squeeze this obviously way more because you can see there's way more space in this. At the same time, you will see that an infill like this, it's almost like moving. This is very decorative. We use it a lot if we want to have a nice sole pattern or something concentric, always makes like lines that follow the outside. But this is not a strong infill at all. So where this is a much stronger one. So all these settings are made in your slicer. This is nothing you have to do in a 3D modeling program. You have a cylinder, and that exact same cylinder we have here in really a gazillion different settings. I usually also print it in a transparent filament so that you can see a little bit what everything does. See it also a little bit through there. Here I have one that we did on a double nozzle, so that inside the infill in a certain color and then the wall in another color. This is a gyroid. So I always recommend, and especially if you start with printing, but also if you start with a new printer, is simply make a whole bunch of swatches for your reference. So that you say, okay, I'm going to make a cube, and I'm going to say, here's a gyroid infill, 5%, 10%, 50%, 20%. I mean, so that you also can feel what each infill does. Because we've had it a lot where people start with printing and they feel that they need to have a very high percentage of this infill, of what is in here. So in the slicer, you set what type of shape do I want here, but also what type of density do I want here. And also, Diego mentioned before, the thickness also of this you can adjust. So all that determines the way that your model behaves. You might not see the infill on the outside, but it definitely it determines the full functionality of your shoe. Is this going to be too hard, too soft, just right? Does it have the right bounce? So especially if you're inexperienced, by now, usually we have done so much printing that if I see a model, I was like, nah, I do this, gyroid this much, this is going to be zigzag that, this is going to be, but because I've printed so much. If you've never printed, simply start with these simple things. And it's always great to have a little swatch book for yourself with all those little infills so that you know what they look like, what they behave like. Things like we have here, which is a gyroid, is usually a strong one and is flexible. But as soon as we are looking at things like here, where we have the triangular ones, you have several ones, you can see I can hardly even squeeze this, even though it's the same density as we might have here, you know, but I can hardly squeeze this. So for instance, say the other day we were working on this new material that is actually, in our opinion, a little bit too soft for footwear. So we printed it in a gyroid, and indeed, you put your foot on it, it goes flat. So then one thing that you want to try is not change the model, but change the infill. So you could then go from, if this material is too soft for the sole, but I love it for the upper, can I then change the infill for the sole in a way that it becomes more stiff? And that's when you, for instance, would opt for something like this, a honeycomb, a tetrahexagon, a triangular, all the ones that are actually not very bouncy, but if you make them in a very soft material, they might result in the ideal option that you need. So there's not just one infill that is always the best for everything. It really depends on what you want. And what you can also indeed do is throughout your shoe have different settings in different places. So let me see, because I had some shoes here. Yeah, let me start maybe with this one. This was a fun one. You cannot feel the weight of this, but this is the shoe from Kedar that you might recognize from the Zellerfeld website. So this is one of the models when he started developing here. This shoe weighs a ton. You cannot see it, but this is really heavy. So here you see that we have parts in the shoe that are walled, so closed, that are smooth, and parts in the shoe that are open walled, where you have the texture. This simply means this texture is made by the printer. This simply means that we give no wall. Now, in order to get a nice texture like this on the outside, you need a relatively high percentage. The problem is that of density, because if I make this a very low density, the structure becomes very open and too loose for the shoe. But the problem is then, if I have that same density through and through, and that's what's happened with this shoe, if you would feel it, this is like 1.5 kilos of shoe. It's really heavy. If you have that all the way through, all the way on the inside, that is way too heavy. You only want that for the outside. So what we will see today in the printing demo, there are in the slicer some options to section off a part of the shoe and change the settings there. If you want to do it as refined as here, where you would say, okay, this part, exactly all these waves, this is walled, even on the bottom where you could see this was walled and the rest not, then you have to do it in your modeler. So this means if I want something like this, if I make my 3D model, that I have the model in several parts. So there's the part that is here open walled, and then essentially these waves that he had coming around it is like a separate cage, a separate piece of your 3D model. If I don't do that, then I'm not able in my slicer to say, oh, I just want these specific parts to be walled. What you can do is, let me go for this one. Dela sitting next to me with a whole pile of shoes in her hands to show what we do. This one is made in pellets, but it's exact same principle. I use this one a lot to really show from a beginner level what is wall. So this whole thing, so this top, this upper, this is half a shoe. It's a failed shoe. We keep a lot of our failed shoes so that I can show the inside of what was happening. So you can see here that it's walled all the way, quite thick walls also, but this is a very soft material. So here we also needed it. If we would not do that, it would be too soft. And then indeed we have a gyroid infill here. It's also fairly soft. If I would then say, well, I want only here in the back, like a block, I want to have it denser, then I could make indeed a cube or a rectangle around it. And then I can make that denser. That's something that I will demonstrate to you today. If you want to do it really refined in a shape, then you have to do it in your model. But what you will see is that again, in the slicer here, I have another shoe from Kato. This is the one that was from the Blender course originally. That also, again, how it comes out, part of that is your slicer, and part of that is, again, the settings of your material and your nozzle. So here I have the same shoe, which is one that failed and one here. This is the exact same settings in the slicer. This is a fully open walled shoe. There's not a walled piece in there. But one is 1.2 nozzle, which you can see very coarse. And this is a 0.4 nozzle for the same. So it really depends on what you want to achieve. What I personally find is that indeed, when you use this thinner nozzle, that shoe becomes a lot softer than this one, although this is also still definitely soft enough to wear. It's just, but that's my personal opinion, in the 0.4, as opposed to the larger nozzle, you might lose some of the texture, because this looks nice if I hold it up close to camera. If you wear this as a shoe, people don't even see the texture, because you basically see it like this, or you see this, and then here you see more that there's a texture, and here you don't really see all that much that there's a texture. So I had that same issue with my Zellerfeld shoes. I got the one from Nolan Kim because I thought beautiful texture. I wish I would have gotten them in the off-white. I simply don't like the color, but in the off-white, you see it way better. In the black, my beautiful texture just basically disappeared. And I feel that that shoe, since they use a 0.25 nozzle, so very fine on the outside, on my feet and from a distance, it looks like a big black blob. And and I'm a little bit, I'm like, okay, but that's just, it's all these things to keep in mind, right? Because especially if when you're designing, you're with your nose against the screen, you're looking at all your 3D and it looks maybe whoop on the screen, but then when you print it out, you're like, yeah, oh, okay. Don't see that so much. So also here, this one was one that they made for me, obviously in pink. Same one. So this is also the same effect where you would say, okay, here walled, here open walled. This was also a 1.2 nozzle, also really fast print. But you do see the texture, all this type of stuff. I think is very beautiful, and this is really, really simple to do. So that's always the good news, because when people see the shoes, they're like, what 3D modeling software are they using for these textures? Like, there's not a 3D modeling software. This is just open wall zigzag infill. Very simple. We will show it today. For those of you a little bit more advanced or having a double nozzle printer, indeed, I've shown similar shoes before, but also here you can see that I'm playing, for instance, with a wall that is transparent and an infill. This is a gyroid infill. That is on the inside. Sorry.
Both are TPU, transparent, and the other one.
Both Filaflex. So this is a Filaflex transparent 82A, and this inside is a foamy, the foamy pastel colors that we made with Recreus. And there is a trick that you have to do. If I have time, I might show it. That's a little bit more the advanced stuff that you actually need to follow our course for. You see maybe the difference here between seeing the gyroid like this, and here's another one, which had the exact same settings almost, but here you don't see it so nicely, because here the lines of the infill, there's a setting that says, make the lines of the infill connect. If you do that, you get this. If you don't do that, let me see if you can see it, then you get this. This is what we wanted. This is the coral-like structure. So there are still some tweaks sometimes that you need to do. Here's also another one. You could also think already in your design, of course, how you want that. This is a shoe that you can actually download from Recreus website, from Filaflex. This is one that they made. I also have the model in the 3D printing course. So in the 3D printing course, you're going to find the model for this. And this is indeed a model in several parts, because you can see here, this is walled, this is not walled, this is walled. So all these parts that you see the differences in are separate parts in the model. So you have this top bit, you have this bit, you have this bit, and then you have this. But once you have that in the slicer, if I want to say, you know what, I'm going to make this closed and this open, I'm going to do it reverse, or I'm going to make it all closed but only this open, and I want this much more open. All these things are just a matter of a few clicks then. So if you have a nice model, you can make a million varieties in your slicer, both in aesthetics and in functionality. So how stiff do I want the shoe to be? How loose do I want it to be? So that's really the interesting part. And for those of you in the textiles course, yeah, you will use the optimal magic of the infills, where you're actually making full patterns with infill. So, Mitch, you want to ask something? I see you pop up.
Yes. I read somewhere that for athletic shoes, that a good average durometer is 55 Shore A durometer. For the, I think that was for the
foam.
midsole.
For foam, maybe. Yeah.
So I'm wondering, can we replicate that that same kind of feel that we get from the the typical athletic shoe? Because I notice we tend to, seems like we tend to go with the for speed, we tend to go with the harder durometers, like maybe 90, 95A, and then we soften it by creating a lattice structure.
Yes.
But
Exactly.
doesn't that also increase the thickness of the shoe? And is it possible to replicate the typical athletic shoe, which is maybe a thinner,
Yep.
midsole?
So this is where I can be quite short because we've been involved in a lot of research things. Yes, there are lots of ways that you could make a performance shoe in a FDM printer. If it's about replicating the exact features of a foam, then no, because the problem that you have is you want to have a really high energy return, good bounce, good compression set so that it keeps bouncing and doesn't sink in, right, over time. And you want it to be incredibly lightweight. But you have to realize that the foams 55A that we're talking about are usually EVAs, not TPUs. And TPUs are generally already heavier materials, stiffer materials. We can definitely do 55A. The transparent slice of the 55A. I'll show you a 55A because we have a 55A printed sole with a pellet, because 55A you cannot print in filament. 55A you print in pellets. My personal opinion is that, because that's why I disagree, this is 55A and very soft. However, this has almost zero energy return. This is so soft, this is like a silicone, like a gel almost, that it's soft to the foot, but what you want for a running shoe is that it gives you that lift off, right? So that you are propelled forward, basically, by your sole. And a foam just works differently from a lattice. And that is definitely where you have to find then the right balance. The lattice needs to be a bit stiffer, because we're comparing now a chemical bounce to a mechanical bounce. And a foam has a chemical bounce because it has like air in it. It's just the softness of the material, the way the material is made. And we have to try and replicate that in a structure. And our experience is also exactly the same, that you will have better results making a slightly stiffer lattice that has a much better energy return, and then make that fairly open in order to save material and bring down the weight. So, but you also have to realize that compared to making foams, printing is in its very early stages. So people think, oh, this goes so slow, but it doesn't. It has taken the industry 50 years to make those foams, right? This is not from one day to the next. So, and apart from the foams, we're talking about the injection molding technology that has also increased a lot. So for those of you who are familiar with that, now we go to what we call supercritical foaming, which is done with under pressure with gas, essentially, where you would make those popcorn, like eTPU, we call it soles. So it's completely different processes and machinery that are nothing like what a printer is. What you have to keep in mind, what you can really bring to the table with printing as a general thing, that's regardless of slicing, is that it can be custom. The thing that is very hard with molding, since tooling, especially for things like supercritical foaming, where you have the really soft popcorn soles, highly expensive tooling. So that's why they don't do them custom, because it's mass production, because it's such expensive molds. In what we can do, we can make it custom or semi-custom. It doesn't have to be all one-on-one custom for your customer. You can also say, here I have my lattice and I have it in 3-4 different densities. That was always my criticism. Also, when I was working for them, I've worked as a consultant for Adidas for a long time. Also in the time that they were starting with Carbon, that I was never in favor of the fact that they made those lattices generic rather than making those custom. So that is the thing that, sorry, somebody's trying to get in. That is the thing that I think printing can really bring to the table.
So can the FDM printed shoes compete with the athletic shoes that are out there for performance?
No, for the moment not. I'm not saying that they never can, but there needs to be much more research into material combination, different types of lattices, different types of printing. But it's not that easy that you can indeed come in and say, oh, I'm now going to start printing, and my print is going to be the exact same performance as a foam that has taken 50 years to develop. So that's where I'd be like, if you're going for high performance, I would probably opt for a combination between printing and foam. So it's not going to be the easy one. But where you can have a lot of advantages over regular athletic shoes is by making a lot of things custom to the wearer. So, and that's also where I think you can do a lot for people that are in sports performance. But one-on-one comparing a lattice, an FDM printed lattice to a foam is hard. They're trying it in the powder space. So in the, because you have, for instance, the people from Hewlett Packard, the factory has now been taken over by another company called Something Added. They make really advanced lattices in powder for sports footwear. They are getting close, but also for them, it's still not that you can easily do that. And then we're also talking about a very different price, right?
Yeah.
So I think already in general, when you want to go into sports footwear, you have to make sure that your business model is indeed custom and on demand, because we are producing those foam midsoles in literal seconds, and we can, even if we match performance, cannot produce those lattices in this time frame.
Okay, thank you.
So, Ryan, tell me.
You just mentioned a combination of foam and like 3D printing together. Is there examples of that have been done? And I think I've seen Zellerfeld have like a Air Max combo, but I just want to hear from you.
Yeah, the Air Max combo, it's indeed a combination with Air Max's actual air bubble unit that they put in there. You also have very early examples. If you look up printed shoes by, let me see, the Under Armour ones that were really early on the market. Let me see. So what you can do is something that we call co-molding, and that essentially means that you print a part and you insert it in the mold. So I can show you here. You see, maybe this one. It's actually already a bit older. Right, so here we have, you can see on my screen a bunch of shoes. This is the Under Armour one. It's really older. I think it's 10 years older right now. This is one of those. So here you see a foam sole. So all of this foam midsole, and then you have this lattice part here. I also see a lot of advantages. Echo has done an example of that, where there was a cup sole and then the lattice inside. Because the disadvantage of lattices is indeed that they're open. So whenever you publish shoes like this, immediately consumers will respond, oh, this is a poo collector, this gets dirt in there, which is indeed true. If you go running in the gym, no problem. If you go trail running, there goes your lattice. It fills full of mud, it loses its functionality. So yes, it's a nice aesthetic that screams to people print it, because this is now how they recognize that. But it would be better for some functionalities to say I basically cover it so that it's closed on the outside and does not get the dirt in there. So I'm always in favor of combining the best of both worlds. There's things that foam do well, and there's things that lattices can do well. And I would love to see shoes like this. I saw ages ago, but I would really have to look it up, a shoe from China, where essentially this lattice bit was like a cassette that you could interchange in the back. Those things make a lot more sense to me, where you would say, well, let's make a lattice custom or semi-custom to the wearer, and the rest is the same. I mean, I could imagine I'm a big woman, so if I stand on a lattice, it needs to be firm. And if I would sell something to a much smaller person, that lattice will probably not be, it will be way too stiff for them. So I'm always like, the things that we can do with printing, the advantage that you have with printing is customization. And it doesn't have to be one-on-one. It could be also say, I offer 4 densities of my lattice, and depending on your, technically you want to know weight, but you could ask height maybe, because weight's always sensitive to ask people. But it's much more in that direction that I think we could have much better solutions. But replacing the entire foam bit with printing is not yet at the level where it should be to get to that level of performance. Okay, well, let's jump into some slicing, because otherwise we are losing our time in really good conversation, by the way. Should I not be able to finish all the slicing today, we can always do a little bit still tomorrow. Tomorrow we have, also good for you to know, we have an experience exchange, so we have different people joining us with different projects, but you're also more than welcome if you have a project you'd like to share, or you would like to have someone's opinion on, or you run into an issue. More than welcome to share. That's what this whole thing is for. So the class is not meant to do super in-depth on slicing, because then by all means follow one of our trainings. But I will go into a good base demo of slicing, and the rest we can do then tomorrow. So yeah, okay. So let me open Cura. Let me see. Here we go. Let me share that. And yep, here we go. So can everybody see this now? What I have, I kind of lost my screen. Okay, the way I have it now, I cannot see you guys, so if you want to know anything, just interrupt me. So what I'm going to do is just do a first simple slice, and if we have time, a little more advanced slice of a simple slide. And I intentionally took this shoe as a simple shoe because a model like this you can slice in many different ways. So I have now positioned it horizontally. We already talked this week about indeed printing vertically or printing diagonal. And the good thing about this model is you can do all of those. So it really depends on what you're trying to do, which parts are you trying to keep clean without support, how do you want to work with this. So say if I have this model, say that I want to keep my sole profile really clean, then I would probably not print it horizontally, because there will be supports under here. So I can then start saying, okay, I'm going to turn my model. You can then say, okay, I'm going to turn it with the sole up. So for instance, what I've now done, I've skipped a little bit of intro, because otherwise it's going to take too long. If you have a new slide, if you have a slicer and you just start printing, the first thing that you have to do is add your printer. Otherwise, it's not automatically recognizing that. That you will do, this is this in Cura. Up here, you see essentially the main interface. This is how you bring a model in, open, and next to that you see the name of your machine. If you don't have a machine yet, this is where you say add printer. And then you can choose. Cura is software made by Ultimaker, by the way. Forgot to say that. It's one of the main used slicers, but it's not just for an Ultimaker printer. Ultimaker has just been on the market for a very long time. This is why this is a slicer software that's used a lot. So it could be an Ultimaker printer, a non-Ultimaker printer. From here, you have a whole dialogue that you can have. It's very straightforward, where you can add your printer, and probably, I'll click here, it could be already in a list. So maybe if I say I want to add a non-network printer, because it can try and find it on your Wi-Fi, or you can say it's not on my Wi-Fi, and here you already see a ginormous list of brands. So for instance, the Elegoo that we are on now is also already in here, Elegoo, and then you see all the models, and here's the Neptune 4 Max that we work on today. So this is really simple. You can probably already find your printer, and if not, you also have the option to really put in the settings. That's mainly about how big is my print volume. So that I'm not going to do fully in detail now. We're just going to say, okay, you have your printer, and now we start slicing. So if we're looking at the screen, you see a few things first on the top. Prepare. This is the mode when you are still setting all your settings. Preview, this is after you've sliced. So I've already done a base slicing here with fully open wall, then you can have a preview. And then monitor, this is while your printer is printing. If your printer is not connected on Wi-Fi, then this is no use to you, because then you cannot follow that. You just follow it old-fashioned by looking at it. So, but you can indeed definitely connect your printer on Wi-Fi, and then you can see usually here if you have a camera in there, and otherwise it just monitors the different parameters that it has. Here in the middle, we are setting for this printer what material do I want and what is my nozzle size. So we have a 0.6 millimeter nozzle on our Alico, and we are going to use, just for the ease of it, a TPU 95A. It starts screaming a little bit that I don't have profiles. I mean, it's fine. we will make a profile for that. You will also see that if I click on the shoe, on the model, that you will see a bar popping up here on the side with different icons. I'll go from the top. So top one is move. So here you will see some arrows. You can just simply use an arrow to say, okay, I want to go this way, this way. I usually turn with my mouse a little bit. That's your right mouse click to kind of turn maybe the bed so that you can see the angle that you want. Here you have scale. So how big is the model? Usually if it's a full shoe, we're using uniform scaling. So you want to scale everything the same amount. But if not, you can click that off here, uniform scaling. If I say I only want it longer or flatter, this is something we use in textiles a lot, but this is not something that I would use in footwear so much, because then you have a distorted shoe. What we do use a lot is the one below, rotation. So then indeed you see, very intuitive, these circles coming around the shoe showing the different directions of rotation. So what I'm first going to do is, so that you can see it well, turn the shoe a little bit straight. I always, by the way, when it comes to shoe placement, recommend to do the shoe either diagonal or straight from the side like this. And the reason for that is that if you start printing, that you can then see well what happens. I have also had people in courses who position, for instance, a shoe like this, and then want to put it vertical. It's fine, it will print, but you don't see very well what's happening, because part of it is happening hidden from your view. So if you want to follow the printer, I usually advise go straight side or go diagonal like this, but at least so that I can see what my printer is doing. So in this case, I could also say, well, what direction am I going to choose? Because, okay, in this shoe, because it's an open shoe with a strap, you will have supports no matter what. So the question is more, where do I not want them? So what part would I absolutely want to keep clean? So I can imagine, say that you have a beautiful sole profile, then you would go for something a bit like this. So where you would say, okay, I want to keep that free. I'm expecting now that I will have supports probably all the way under here, maybe also inside the shoe up here, but it does not necessarily always have to be a problem. If we want to make sure that the shoe sticks to the bed, then we can actually add an extra brim here that will keep it straight. I'm going to slice it just for the fun of it in this way, and then we might see another way after, because this model you can do in many different ways. Also, especially if you're inexperienced with slicing, try your models in a bunch of different ways. Slicing goes quite fast. So once you have the settings that you want, then you can try a bunch of different orientations to see which orientation gives me the least support or the least printing time. I mean, and it also helps you to understand what the printer does. If you want, you can flip, which is always handy. So of course, that's how you print a pair. If you have a shoe, say you have your 3D model and it's a right shoe and you want a pair, then you just flip it and then you have your left shoe, provided that you want it symmetrical. So one remark there, I generally do not advise necessarily to print both shoes at the same time. And the reason for that is that in flexible printing, we have a lot of retraction. So that means that when the printer is printing and it needs to go from one model, for instance, to the next, it needs to pull in the filament and then travel to the other side and then extrude again. And what you see is that a lot of times it keeps extruding a little bit because the retraction is not strong enough, and you have threads continual threats between your models. This is also why, if we're looking at a company like Zellerfeld, everybody has started from, we're going to print single shoe. Now they have a new type of printer that can mirror and where they indeed have separate nozzles. If you have separate nozzles, then no problem. Then one nozzle prints the one shoe, the other nozzle prints the other shoe. But if it's one nozzle that needs to go back and forth between the two shoes, don't get the best result. Also, if you have a failed print, then you have two shoes failed instead of having one shoe failed. So I generally don't advise that. The things here, I'm not going to show you now. These are specific settings to block off supports, to block off different parts of the shoe in different settings. We can have a quick look at that, but I'm not going to start with that because that's more advanced slicing. So now here on the side, you have all the slicer settings. And what I'm going to do is I'm going to click off these things for now, because the one risk with slicing is that people get entirely overwhelmed when they see it for the first time, because there's a lot of settings. So I'm first going to go over the basic principles of it. What are the different things that your slicing is asking you for? First thing is quality. That simply means how fine is my print. So what is my layer height? Do I have like really thick layers, really thin layers? And honestly, that is related to your nozzle size. Because of course, if you have a very thin nozzle, you cannot make big lines and vice versa. So rule of thumb, I think I mentioned it before in one of the classes, for layer height, take half of your nozzle size, maybe round it up a little bit, but general rule of thumb, good rule of thumb is half. So say that we have a 0.6 millimeter nozzle, you could do a 0.3 layer height. So that's in quality. We will see that after we're going to set these settings, but I first want you to know what are the things that the slicer is asking for. Then walls. So like we talked about before, those are the sides. Again, a printer looks at top, bottom, walls. And so bottom is always what is against the build plate. So in this case, bottom layers are going to be like here. Top is what is most at the highest Z height, what's sticking up. And walls are everything that's around the side. So that's something to take into account. It differs what is wall and what is top or bottom with the orientation of the shoe. So this is something that you need to take into account. So you can set walls, you can set top and bottom. All these things you will also find in Bamboo Studio, by the way, but maybe in different places. So the elements of the slicer are always the same, but you might find it in different places. Infill, we talked about before. So this is the filling, what's going to be on the inside there. What is my material? So that usually also has to do with how hot do I need to print my material. Main thing is temperature. Then we have the speed of the printer, and there we have two types of speed. The one speed is how fast do I extrude. So that's also what Emad was mentioning. So his like volumetric speed or flow speed. This is how much material is being pushed through the nozzle and how fast. Then, and how fast does it move? And then you have the travel speed. How fast does the nozzle move? Travel speed, that's the speed between extruding in a layer and then going to another part of your model without extruding. And that part where it's not extruding is travel. Cooling, you have fans on your print head that are cooling the filament down. That's especially where we will have for flexible material entirely different settings than you would have for PLA. Then we have support material, the biggest difficulty usually in printing. You have build plate adhesion. So how does this model sticks to the build plate? There are some mechanical things that we can do. By the way, oh, maybe you want to get those. Are glue, the glue stick and the spray. Yeah. You all might have very different ways of sticking your model to the plate. Usually when people are new to printing, they think that they need to keep their build plate as clean as possible. No, you don't, because the one thing that you really want to do is make the model stick. One of the things that is difficult with the flexible materials that we have, also, by the way, with other materials, is that it often does not stick to your plate. So then you're printing and halfway, whoop, your model falls over or gets shoved off your plate or whatnot. Simplest way, still, in our case, I mean, you can buy different things for it, and different plates and tape and whatnot. But simplest way still is, and also cheapest, glue stick. Cheap hairspray. That's at least still our magic combination. Glue stick on the plate first, hairspray over, bit gooey, and then print sticks perfectly. So I can definitely recommend. Then the last bit we are not going to do today, that's dual extrusion. This is for when you have two nozzles. So then you have to set which nozzle prints. Any questions so far on the different topics before I go into the settings? What we do.
You tried with spray mount on the.
What was for the spray? Sorry.
Have you tried with a spray mount? You know, with the yeah. No.
I have not. I can also try that. We're always open for new for new trials. So spray mount. No, have not tried. Good. Do you have good experiences with that?
No. I just I just thought that hey, maybe it works. Yeah.
I don't know. I mean, I know that, for instance, Philip from Fused indeed simply uses a glue gun. Also works. So it's just the glue is a little bit more difficult for me to get off the plate because indeed I do not want to have humps or bumps eventually. What we like about the hairspray is that it's quite thin, so that it's creating a thin layer, straight layer. Yeah. Other question?
Yes. How
Yeah.
often do you resurface the build plate, or do you just keep adding more glue stick and hairspray?
We usually touch it a bit, kind of like by touch. We're like, is it still enough? Or if I suddenly have a much bigger print that I need to do, then I usually go like, let's put some extra on it. So, or if I do think that by now there's really like a sticky crust on the crust starts forming, then I will clean it and then still put another layer. But you don't want it to be where you have humps and bumps on your build plate. So that is the thing. So now you have a lot of the build plates that are flexible. So you basically, once you have the print finished, that's also on both on the Elegoo and on the Ultimaker that we have. You take the plate out of the machine and it's something that you can bend a bit and then the model snaps off also. So that's also usually quite clean. But other times we usually have like a spatula to kind of take it off. It's like baking pancakes, pretty much. So what I've done now, by the way, which is also a good tip if you are a beginner, is that if you are looking here, you can see what print profile and what settings do you have. And here you have the little hamburger. If you click on that, you can choose different types of settings. So you can choose basic, which is essentially what I have now, where you have only a few, I'll open them up, only a few settings per subject. If you just start, it's usually enough. Once you get more proficient in slicing, the way we have it is all. And then, usually that's quite a lot of settings. So that's usually where you are then. If I click now everything open, then most people go absolutely berserk if you see that for the first time. So I do not recommend that you start doing that for the first time. But you can see here how many settings for each part there can be. Again, not saying that you need to change all of those because there's also many of them that we don't use. But there are some specific ones that can come in handy now and then. So it's always good if this is all new to you. That's also why I like Cura. It's quite logical because everything is just below each other. You have a whole list, so you can go from this to that. That if you if your mouse scrolls over something, so you just put your mouse on it, then you already see a little window that explains what is what. So if you don't understand what something is, it tells you, okay, here, wall thickness of the wall in the horizontal direction. So what does it relate to? What does it connect to? So these are always good things to see. And sometimes by reading all of this, you can see a description of a setting where you're like, oh, maybe this is interesting. Because the slicers update all the time. I also find that sometimes a big nuisance because it's literally every 2 weeks. Where you're like, oh, another new version. But indeed, sometimes there are new settings where you're like, oh, that's handy. I would like that. Now let's start with a simple slice. So quality, we can be short. Like I said already, 6 millimeters nozzle, 3 millimeter layer height. Then I can say, how many walls do I want? So let's say that we first do one with walls, and then I will show you one without walls and show you the difference. So just going to do on average for the side, you could say 2 walls should be enough. So 2 layers. Again, depends. If you have a very open infill and it has to cover that, sometimes it's not enough. So it's also a little bit trial and error. You can always, when in doubt, print first a little cube or something small with the setting to see what it looks like before you go do your whole shoe. No need for us to address horizontal expansion at this time. Top and bottom thickness, here it has already said 0.8 millimeter. I think that can be a bit more. So say that I do just average 3 layers top, 3 layers bottom. I could also, if I want this to be thicker, say I simply want you to make 1 millimeter, and then you also automatically see that it makes the layers, it increases the number of layers. So whatever is easiest to you, right? Whether you simply want to say, I want the wall to be exactly this thick, or I simply want an X number of layers. Then here we have the infill. Generally, when you are starting, so here you have infill, you have 2 things. You have the density and the pattern. I'll start with the pattern and then the density. So when you click on pattern, you have a whole list. And Bamboo has an even larger list. So I don't know if somebody's chatting to me now because I hear things plopping up, but I cannot see that. So if there's anything that you need to ask me since I'm in full screen, you have to ask me.
Yes.
Yes.
Yes, how astute of you. I was wondering, do you worry about the thickness being or either the wall or the top thickness being an even multiple of your layer height?
Not necessarily.
Like with a 0.3 millimeter layer height and a 1 millimeter
you would say,
thick.
I need a 0.9, right? Yeah. You can do that. In our experience, it does not necessarily matter all that much for the print. So here it basically just tops it up. The printer adjusts for it, so it will basically bring the layer height down in that side. But it's a good question because you can definitely do that. I'm very much used to thinking. I usually start with thickness because I'm kind of used to how really thick I want something, and then have the printer calculated. But you can also do opposite. So here we have all the different ones. I will point out a few different ones that are used a lot. So gyroid, which is a lattice, is a really good one to have comfort in footwear. It's one that we use a lot. If you want to have the Zellerfeldian look on the outside with an open wall, you choose zigzag or you choose lines. Either one of those are usually used a lot for that. The one that I would not use out of all of these, because the rest you can try for yourself, is lightning. And why not? Because lightning is a method of infill that is really fast and meant for minimizing the infill throughout your file, but it leads to lots of parts with no infill at all. And in shoes, it usually chooses automatically parts where we have a lot of infill where we want the opposite. So I have never had good results with lightning. So it's just, I would skip it. Density. So how much percentage are we doing? This has very much to do with what your material is also. General rule of thumb, what we do is say that you have a whole shoe and you don't want to diversify in what you have for your upper and what you have for your bottom, then think about the bottom, because that's the main thing where you then need the density. Usually if you have, say, an 80-ish filament, then you would have enough by saying 20 or 25 max infill. Should be enough. Here it says 40, which is what we've done something for textile. I would definitely not do that if I want to make an average infill. So say I do 20. So general rule of thumb, the stiffer your filament, the lower you go in density. If I go for a 95A, I could even opt for a 10 to 15% infill for this. So it's really the balance between the two. Then here we're going to do something quite simple. Printing temperature for I actually have a 95A that I set. You know what? I'm going to do it a bit lower. I thought that I had set my material to 82, set it to 95. So let's do 15. So printing temperature, 242 is just a standard that we use a lot on our printers for the Filaflex material. These details you will always find on the material. So either they're on the roll, or you can go to the website of the filament provider and you will find them there. So that's up to you what you want to do. And usually there's way more settings also that you can do. I'm now going to do the absolute basics, the bare basics. I'm going to take you through to not overwhelm you. Print speeds. This is how fast the printer is moving. For flexible materials, always slow. So usually around 25 to 40 millimeters a second. The softer the material, the lower you have to go. You heard from Nela earlier this week that for the Bellina, she had to shove it down to 15, which is extremely slow. This case, say that we have a 95A, so relatively stiff, we could go a bit faster. So say that I would put it here to 40. I know that the Elegoo would be able to handle that. Travel speed. Here then, here I am going to do some settings because these are important. In travel, you also have retraction, and these are the settings for how much does it pull the material in. So here I do want to have a little bit more settings. So what you can do is, if you see this little slider icon there. If you click on that, you will see all the different ones that you can choose. I am only going to do, in this case, just for the ease of it, retraction distance and retraction speed. So how fast does it pull it in? How much does it pull it in? So yes, we want retraction for sure, because it needs to pull in that filament when it travels to another place. We have just done a calibration test. Oh, do we have to? Yes. So yeah, maybe this one, you have to do the good one. Good advice also for you guys if you're new to this. Also, if you start using new materials, whatever, you can find online, if you Google for that, retraction calibration files. So this is one, for instance, that we printed. It's these two little poles, and then you see indeed all this stuff here is retraction. We don't want that. So a lot of times you have to try different settings with this type of file to set your ideal for your printer, your nozzle and material. Once you have done that, you don't have to repeat that all the time. But let me see if Nela, we've done, yeah, just bring a whole set. We have just been doing this for the Sting 3D material on the Elegoo because we got a ton of retraction in there where we're like, ugh, don't want that. Yeah. So here you can actually see this whole, I don't know if you can see it, this whole paper with all the different settings. And then you see, we hold this in front of the camera, here you see all the different retraction ones. And then here at the end, we had the one, I hope you can see it, that has no retraction between the poles. And so Nela's now going to tell me what that was so that I can put that in. In the meantime, hold on a second. I need to plug in my charger. Wait. Yep, that's a bit stuck under all my shoes that I have here. So, because this was quite extreme for the Elegoo, I must say, for this material that we had, but let's just put them here. What did we have for distance?
Distance was 0.5.
0.5, that's actually really low.
Yeah.
So usually for Filaflex, the distance is between 4 to 6, but depends on your printer. So, and the retraction speed, 14?
But this is for the Sting 3D, so we can do for Filaflex around 1.5 millimeters distance.
Okay. So for Filaflex, it's 1.5. That is usually the best on that printer. On the Ultimaker, I need to put it way higher. And then retraction speed, 40 millimeters a second. We always have a Z-hop. You can also set the height of the Z-hop. Z-hop simply means that if your printer extrudes and it goes from one part to the next, traveling, whether it goes up or not, whether it goes up from your print. Not going to get, I mean, there's a lot we could say about retraction, could do a whole class on that. So I'm not going to do that right now, but these are the basic things. Distance and retraction speed you will always want. If you go to the Recreus website from Filaflex, they have very detailed settings for this, depending on your nozzle size, the material, what you have. Super helpful. So definitely use those, but don't trust them blindly. Always try for yourself, because all this has to do with your printer, your gears, the humidity that you have, the temperature in your place. All of that is of effect.
Quick question. Sorry, quick question
Yes.
about retraction. As a rule of thumb, would you say that a bigger retraction distance helps to avoid stringing?
But
okay.
The nozzle.
What?
That can clog the nozzle.
It can clog the nozzle. Yeah. So that is the higher you have. Well, I mean, for the Balena, we had there a lot of issues. So the harder it pulls it in, the more you have filament inside the nozzle clogging. In general, for Filaflex, I'm usually on the Ultimaker at around 4 to 6. So that's a lot more. So it really depends on your filament. But the retraction, taking the time to do proper calibration for retraction really saves you a lot of hassle after in your printing, that there might be mistakes. Cooling, very important for when we do TPU. No. So there we can simply be really short, which is what a lot of people don't do. Switch off your fans. So switch off the cooling. It will help you a ton. Yes, if you're printing other materials, for sure you need cooling. In the TPU, we don't want it to dry too fast, because it might also lead to delamination where the layers are not attaching. So that is the thing. Then the same counts, by the way. I don't know if we see that here. Let me see if it's... I think I now have a lot of basic settings, maybe in material. Let me see here. Material, you will probably also have... yeah, here. I forgot to mention it. In material, you have the printing temperature of your material. So how does your material melt? But you also have build plate temperature. So many of the printers automatically suggest 30, 60, whatever, 0. Switch off. We don't need heated build plates for TPU. For rigid material, yes, you do need, because otherwise the print certainly doesn't stick to your plate. For TPU, general rule of thumb, no build plate heating. That's also why we use very little energy here, especially even when I have all the printers on, I don't have heated plates. So I'm not cooking, basically. So in that sense, also saves me a lot of time. Same for cooling. So build plate cooling off. Generate support. Yes, we have to, because I mean, I can say no, but well, yeah, then my shoe doesn't print. Here I'm going to go quite simple, because there's a lot that we can do in support. If you follow our courses, we go much more in depth. Let's talk about a few things. So support structure. What do we want? Most printers, also the Bamboo, have both options, and some more variations in the Bamboo even, where you have normal. So this is like let's just say the straight pillars that we know, or tree, which is a more recent solution, which creates like these branches that go around the shoe. I think for a shoe like this, where you have openings in the shoe, definitely I always choose tree. But you can always see, when you see the end result, where you're like, the disadvantage of tree can be that it might not be enough in all areas, because one part that the support also does is to keep the model in place. So for instance, here, if I'm slicing this, the support that will have to be under here is also part of what's keeping the shoe in place while printing, because this shoe is kind of like hanging there, and then the build plate goes like this. It starts shaking. So it might be that you're like, yeah, nice, but let's not. And in that case, we do regular. Support overhang angle, we've always cranked it up. Standard is 45, and that simply means that anything that is more horizontal, so below 45-degree angle in your model, will receive support. Anything above does not need it. If you want less support, you can always play around a little bit with the percentage, and especially if you are experienced and you're like, yeah, I think it will do it. We also even have prints where we crank it to 60. But if you are a beginner, I would not advise that. So start from 45, 50 maybe. That's fine. Build plate adhesion. Let me click it open. Let's see what they have. Okay. This is how does the model stick to the plate. This is like extra support that you can add. And we definitely need that here, because there's very little surface here. Only this little edge that keeps the that sticks the model to the plate. So here we want to say yes. So what are we choosing? Here's a few different things: skirt, brim, raft. So a skirt I use a lot of times anyway. A skirt simply means that as you start printing your model, before it starts on your model, it prints an outline of the bottom of your model in a few lines. I always advise to always, if you don't have anything, to have a skirt, because then at least you can see that it starts extruding, because sometimes you see, oh, bugger, my nozzle is clogged. And you would much rather see that before it starts on your model than already having a half-filled print. What we will use a lot here is brim. It's simply an extra edge that you create around the shoe, but it doesn't go underneath your model. If you want to have a really strong adhesion, you can do raft, but we never use it. This is essentially the same thing as a brim, but it goes also underneath your model directly, and then you cannot remove it. So brim is very easy to remove. It's not attached under your model. It's just a sideline. So I'm taking brim here, for instance, and now let me see if it allows me. Let me do another setting change, because I do want to set my brim width. Here we are, brim width and brim light count. So here, standard, it's usually just a little bit. For shoes like this, we need a lot of it. So because this is holding your shoe in place. So here, I would basically say make it 5 centimeters, 50 millimeter. So, okay, this is now the base settings that we have done. And we could finally click slides. Since we had a lot of good questions, I'm a little slower than planned, but like I said, so then tomorrow, instead of now speeding up and go, Bamboo and other settings, I can also continue tomorrow, because especially for people who are beginner, this can be a lot, to show you a few of the other things. So, okay, slicing. So now already here, we're not seeing the preview yet. We'll click on that. But here's the first thing. It's 1 day, 12 hours, and 30 minutes. I expect to see a lot of support if it's this long, because it could also have to do with the fact that we have a fairly small nozzle. 0.6 is not a very large nozzle. It's also not the smallest. Also here, you see already right away how much gram does it take. So 596 gram. If you have a scale where you print, and you know, it's always wise to weigh the spool without any filament. If you have an empty spool, weigh the spool so that you know how much more or less is a spool. Put your spool with filament on the scale. If you are in doubt, subtract the weight of the spool so that you know more or less, do I have enough? Because you cannot really see usually in the roll. On average, you have rolls of 500 grams, 750 grams, and a kilogram. So if you have a 500 gram roll, a small one, then you would see, not enough. 750 grams, not a problem. But if it's a roll that you've already used some of, then it could be good to kind of check. It also says here, how long is it? If you are also in your material settings, that's a separate thing that we also do in our courses. If you are also able to set the costs of your material, so how much is a roll and how much is on the roll, it will also already give you the price here of how much this costs in material. We don't see that now. If we now go to preview, you can either click here or you can click up here. Then you will see what this does. I will actually click off these things. So now indeed you see a tree support, and you indeed see, and here you see also my brim. So this is my brim, this big flat slab here. Given the amount of support I have here, I might choose to do it a little smaller, but always rather be safe than sorry. In this one, it doesn't cost you all that much material. It's just one layer. And then here, if we turn around, you see all the different supports that it is making. So indeed, what we see here are supports going all the way up to the front, and this is very likely that these supports go all the way through. Now, how can we see that? So say that you position your model a little bit from the side, so you can see everything partially from the top, say just like this. There's a bar here on the side that shows all your layers, 699 layers. And as you pull it down, you see exactly what the printer is doing. So here you see our gyroid infill. Let me show it from the top. walls that we had, and here all that bluish turquoise stuff is support. So here, definitely we can experiment with other positionings of that shoe, maybe have it lean forward a little bit more, that we don't get all this support going straight through. It doesn't seem to hit the wall all so much, because what this support is actually for is mainly for the front part. So we can try different angles where we say, okay, should we go more vertical? Should we go more forward? That's very easy to try. Once you have done your settings, you can play around with your rotation, your positioning anyway. Say I make more vertical, more or less like this. As soon as I change something in the position, I can do that in the preview window, but then it will say no layers to show, because you have to slice it again first. Because of course then the parameters all change, and then I'll slice it again, and let's see, we had 1 day, and I don't remember exactly how many hours. Let's see if we have less here. Yeah, already less than a day, 23 hours, 5 minutes. So here you can see that this orientation is much better for the model, because you see way less support and only two to the front. And if we see this with the, with the layers going down, then you indeed see that those trees are not really, yeah, no, they're not hitting the wall. So this can be fairly easily taken off. So my only doubt with this setting is that it might move, because it doesn't have so much to hold it down, and especially since this tree only hits a little bit here and then goes straight to the front, but does not touch this. So this will be very easy to remove. You can simply rip it out. Usually that's not so difficult. I could also say, well, no, we've done this orientation because we wanted the sole to be nice. If you simply say, nah, I don't want all that support there, can we not simply print it horizontal, which I would probably not advise in this case, but let's try. Slice it again. Fix a bit. Any questions in the meantime while we wait for the slicing to happen?
Yes, a lot.
Okay, oh, perfect. I can get to those. Okay, so how does this look now? Here in this orientation, I will say we probably don't need this type of a brim, because now if you have this orientation, you have a lot more surface of the shoe sticking to the plate. But you will see that here you also, since you have the curvature and these are complete overhangs, that you will have the support here. You will probably also have support on the inside. Yeah. Here I would probably start tweaking with the density of the trees and how much, and there's a lot more settings that we can do. But it's just to explain you the base principle of where supports are. So again, as soon as you have something horizontal, the more horizontal you have it, the more support you will have. So this is, of course, this curvature on the bottom, near horizontal. It cannot print in the sky. This curvature of the strap, essentially. It cannot print this in the sky. There will have to be support. On the other hand, since this is fully open, you can remove this quite easily. So it depends on what you want. If there is a, say for instance, you have a specific footbed in here that you want to be clean, then you might want to choose this type of orientation. But if you have a beautiful sole profile that you don't want to have support on, then indeed I would choose the orientation that we just showed, which is more vertical. So it honestly depends. I can imagine that if you are a professional modeler and you have a shoe like this, I would usually advise to say, make the whole inside, so the place that you stand on, as well as the inside of the strap, a separate shell, a separate part in your model. Because I could imagine that this might look really good open walled, for instance, this shoe, but then make the inside walled, because of course the parts with walls are smooth, are easier on the skin usually, and the parts open walled can be quite rough on the skin. Again, depending on what material that you use. But those are all things to think about. I will stop sharing a second and jump back to my window. So because I heard a lot of hand raising and stuff, but I cannot, when I share my full screen of the slicer, I cannot see any of you. So, or hand raising. So, but shoot with all the questions.
Sure. Yesterday you showed us the Zellerfeld shoe. It had like a woven fabric structure on the outside. It almost looked like it was made out of fabric instead of TPU. Is that possible in the slicers that we're talking about today, or do they have a custom deal?
Custom. So this is indeed why they have built their own slicer. This is a custom slicer setting of Zellerfeld. So I do think that also the regular slicers will start to try and copy this type of thing. But for now, that particular structure is proprietary to Zellerfeld.
Okay, great. As a follow-up, you mentioned for open structures to use zigzag and lines.
Yeah.
Is that also for an open structure surface finish, or is that primarily? Okay.
Yeah, I mean, if you a surface, because if you have the open structure, you don't have a separate surface finish on top of that. Makes no real sense because it would look weird. I can show you, for instance, here. Let me share my screen quickly because that's actually quite easy to do.
What I'm trying to get at is a way to make the shoe breathable without having to do it in the CAD software.
Yep.
So.
Yeah, that's open wall. So that's in this case, so okay, let me first show you how to do open wall because that's quite easy. So we have the model, we go to our settings, and it simply means that you, in the top settings that we have here, when we talk about walls and top and bottom, you simply set it to either in the line count or in the thickness to 0. You already see that this then grays out and it's becoming yellow because then usually the printer is like, the slicer is like, really? But yes, really. If something cannot be done, then it turns red. But yellow is just, are you sure? So I also set my top and bottom thickness now to 0. So that means I have no walls. Now I'm going to change here my infill, for instance, to zigzag. I will then, if I want open walled and I want to have the Zellerfeldian look, let's say that, then you have to go to higher levels of infill, 50, 60. Let's start maybe with 55. Let's see what it comes out as. These are always things, again, also depends on your nozzle size. So let's slice this. The problem is if you do it for your whole model, do we still have the example of the that we tried in the black with the zigzag on the outside and the arbor infill on the inside? Yeah. If you do it for your whole model, it means that it has a 40% infill throughout the shoe, and that could make it quite stiff, which is usually why if you really want to do professional open wall, because now and then it's to a quite long print. So let me look at the preview. This is now what that would look like. I'll zoom in a bit. And this is then indeed what you see also. I mean, this is a smooth shoe. Of course, this doesn't have any textures. Most of the Zellerfeld shoes do. But this is kind of what it would look like. That would be fine as a textile-ish. Is just the problem is that if I now go through my whole shoe, the layers, you see here, of course, that I have that same dense infill everywhere. So this is why, and I cannot really change that easily in the slicer. I could make a block here for the inside, but it does not be very elegant. So in this case, I would advise, if you want to do this professionally, that essentially you would make your model such that you have an outer shell of a few millimeters, and that then all this, the inside and that whole midsole bit, that's a separate part of your slicing. So here, I hope I can, let me stop sharing for a second this and show you this up close. This one, can I show it here? Yeah. So what we've done here, this is also a shoe where there was partially open and partially walled, right? Initially, he had his whole midsole bit, this 40% or 50% zigzag. if I do that, I get a very stiff shoe. So what we did, we made a separate piece for the model that is like inside, where we could say, okay, this is just going to have a gyroid that's much more springy. And then only this outside shell has the dense infill with open wall. So, but that is indeed something that you can only do in your model. You cannot do that just with the slicer. So you would have to, you can do it in the slicer if you make another model that is kind of like the shape of that midsole bit, bring that in and use it as a modifier. That's not something that we're getting in now. That's more advanced slicing. But it's something to think about, because of course the disadvantage of open wall is that, yes, it's breathable and it looks great, but it requires quite a high density to look good. And that density is not necessarily what you want on the inside of your shoe.
Thank you.
Yeah. Okay. I saw that I was indeed missed some questions. In the meantime, in the chat, so Diego was asking, could Recreous foaming get closer to performance foams? Technically, that's the idea behind the foamies. Is just that they are, so they're very, so the good part is they're super lightweight. That's great compared to the foams. I don't think they have the same energy return. So when we use foamy for anything slightly performance related, I would go definitely for the 95, not for the 78, because you need to build a lattice with it that's still relatively stiff. Can you change the nozzle size from the standard 0.4 on the FLSun? Most definitely, yes. I think everybody will have done that. FLSun V400, you can change nozzle size. Absolutely. The printhead is a tad bit complex to take apart, but nothing too serious. So that is the one part that I really love about Ultimaker's very expensive machines compared to others. But the fact that you simply pull out a cassette with the nozzle, pull out another, put in another cassette, and you've changed your nozzle size is such a blessing. So I think that's something that more printer providers should do, because now indeed, yes, you can change nozzles on pretty much all the machines, but you have to screw apart the printhead. So and reassemble, yeah, unfortunately. Other questions, because we're a little bit over time, so I'll take one or two more questions. Yeah.
Couple of questions. Yeah.
Nico and then Daniel. Questions I take. Yeah. Yeah.
Is it possible to get thinner layers, maybe on the top and the bottom, you know, of the Trimo, and slicing in Cura? Because I hadn't.
You can. So there's a couple of options. I mean, you have, first of all, if you choose, so there's two things I can show you. First of all, oh yeah, let me share, because otherwise you're not seeing anything. Hold on. You can either go here to use all settings, at which point we will see way more for quality. Yeah. So here you can already line width and layer height and all that's do way more settings. You have here way more settings that you can do for all the different parts of the shoe. What you can also do, if there's a specific part where you say, I want to really change here the quality, and I think I might better demonstrate that tomorrow because that takes me a bit of work. This is where I would then put a support blocker, and it can be a little bit confusing because I'm simply using the rectangle that this creates to mark off an area, and then I go to per model settings, and then I'm going to change the settings only for that part. And then I could, for instance, say this part, I don't want the layer height to be 0.3. This is going to be 0.1. So, or whatever it is that you want. So you are able to do that depending again on where you want that to be. If say that I simply want to do the strap, in this case, I just want to do that part, then it's easy because I can make a big block around this, section this off, and say here I want it changed. But if you want to do that for a specific refined part, then again, I would advise that you do that in your modeling. So remind me tomorrow that I show, for you, Diego, it's the same as we do in the textile course. So you create a block, put it around here, and then essentially in the per model settings, in the mesh settings, not overlap, you select settings here for different different line width. So
I tried, but it doesn't allow me to change the height, That's problem.
the layer height or
The layer height, yeah, it doesn't allow me to change it. So that's, yeah.
yeah, I see that here also. It doesn't allow me to do that.
Maybe
What
it's a clear thing.
What you can do then, have you brought it in as two different parts of a model? Because I cannot check that now, as two different halves of a model maybe, and say this part, this setting, and this part, that setting.
I haven't. I will try that. Yeah.
We can try. We can see also tomorrow. I've never tried changing the layer height for a part. I don't understand why it would not be possible. But okay, that's something that I would have to also check myself. What you can do.
Second
Yes.
question. Besides, the gyroid or maybe the zigzag infills that have that make like a continuous line, all around the layer. Which ones would you recommend maybe for lattice printing, or to avoid stringing, to avoid like jumping?
Yeah, the difficulty is that actually they all do that. The one that does it the least is concentric, but the problem is it's the least strong one. So you usually don't want to use it unless it's for something that you want to make just look nice, like a nice graphic. So the main advice still is indeed to do a major calibration on the printer because now indeed after Nela spent like a day on these thingies, now we have the setting right.
Okay. Yep.
And now it's printing the shoe clean.
Okay.
Hi, Michelle. That you mentioned before that we can set the connect infill. Is where exactly that can I set?
It's lines. It's in infill. Hold on a second, Daniel. And also that you're also still waiting because I was going to do Daniel's question. Hold on. That is in here. Looking for the infill. Yeah. So here you have, let's see, because it's infill overlaps. Infill line directions. I always have to look at my list. I don't want to do that. Let me see. I can also usually connect. You can always look in here. Infill overlap. Where did the suddenly go? Infill overlap percentage. Connect infill lines. We have done it. I've done it a million times. It could be that I only get it if I choose a certain setting. Let me go back to where I usually do it, because it might be that it only shows me that in a gyroid setting. Right. So for gyroid, this is a relevant one. Now you automatically see if I click on gyroid, then it gives you a connect infill lines option below. If you want the infill to be quite strong, I would recommend to switch that on. But if you want it to look pretty from the inside, like we did with the transparent layer outside, gyroid inside, then you want to click this off, because then you have the difference between closing the gaps between the gyroids on the outside and not closing the gaps. So that was the difference between, let me stop sharing again a second, because then I can show it a bit bigger. Where am I here? This is indeed don't connect infill lines. So here you see the lines of the gyroids really nice and clean. And this is connect infill lines. You see what happens? It starts connecting those lines on the corner. It goes from, if there's the corner of the gyroid, it just goes to the next and then back. So it's the difference between here.
So it's not all the pattern that can apply this, right?
No, it's for gyroid specific. It's for gyroid. You can try. I don't know if it applies for. We mainly use this with gyroids because it's the prettiest pattern for the inside and quite comfy. So that's why we use that. But yeah, that's where I would check it. I know that Daniel, before others jump in, because I was only 2 questions, and then Daniel also had questions. So I still want to have his question, and then maybe other questions we have to do tomorrow. But
well, actually, my question was already answered. I was curious if you had like an example of these separate parts in a slicer. But as you mentioned, you are going to go there tomorrow.
I'm gonna do it tomorrow because it takes me a bit of time to, because I know that as I start doing that, then I'm gonna open up a whole other can of questions.
Yeah, exactly. Yeah.
But
That's how I
it's,
just wait
I'm also
until
gonna
tomorrow.
go super in depth there because that's really what we also do in the courses. But at least I can show you the principle of how do you block off a part and choose another setting. So I can do that.
Yes, perfect.
Yeah. So that's what we will do tomorrow. Was there a really pressing question, Mitchell, that you had, or can it wait until tomorrow? No,
I
good?
can wait. I can
Okay,
wait.
perfect. Yeah, because we're already a little bit late, and so I have somebody who has cooked dinner. So we'll still do that. Okay, so then tomorrow we will do then a little bit slicing, and the rest of the time I would really like to exchange different experiences, so different things that you guys have printed. What did you run into? Eric, who was in the class yesterday, who graduated with us on a really interesting system on how to minimize printing time and material for your models. So it's we have started printing more and more horizontal and changing the way we design shows to greatly speed up the speed. And he will show that and he will talk more in depth about what he has been doing. And there's probably also some other people joining tomorrow that I cannot reveal yet, who are also going to be talking about their stuff. So that's going to be also an interesting class, I think, where we kind of combine a lot of the things that we've been learning in this week. Yeah.
Awesome.
All right.
Thank you.
Perfect.
Thank you so much.
As before, I will post on the YouTube for the other one from yesterday is already on the YouTube. If you want to review anything else. So, and have a good day or evening or night, wherever you are. And I will see you guys tomorrow. Yeah. All right. Thanks a lot. Thanks a lot. Bye-bye.
Thank you.